Okay, I'd like to show you a different method that is probably used a lot more than the substitution method for solving a system of equations. Suppose my first line is 2x plus 3y equals 7. And my second line is 4x minus 5y equals negative 2. So in the back of your mind, you have this idea that we're looking at two lines and we're trying to find the point that's on both of them. Neither one of those equations says y equals or x equals. So we don't have a handy substitute for x or y. Now we could, if we wanted to, we could like solve this equation for y, make it say y equals, and then we would have a substitute. But there's a much better way. If we took these two equations and added them together, then we would have 2x plus 4x, which would give us 6x. We would have 3y and negative 5y, which is negative 2y. We would have 7 and negative 2, which is 5. By adding those two equations together, I've ended up with another equation. Unfortunately, it didn't accomplish a thing. Okay? Two equations is enough. I don't want a third equation because this third equation still has two variables in it. What I'm trying to do, and what we did in the last lesson with the substitution method, is remember, get an equation that only has one variable. So instead of just adding these equations together, I'm going to take the top equation, multiply it by negative 2, and then add them together. Now, why in the world did I take negative 2? Because I was noticing that this was a 4, and I was thinking, well, if this was a negative 4, the very beginning of this course we talked about opposites. 4 and negative 4 are opposites. 7 and negative 7 are opposites. And when you add opposites together, you always get 0. So if this is a 4, it would sure be nice if this was a negative 4, because then I could add the equations together and I would get 0x. I would eliminate the x altogether. So this is actually called the elimination method. I'm going to leave the second equation alone, but I'm going to multiply the top equation by negative 2. Now you got to use your distributive property. Negative 2 times positive 2, that's a negative 4x. Negative 2 times positive 3, that's a negative 6 in front of the y. And the negative 2 also has to get multiplied times the right-hand side, which would give you negative 14. Okay? Remember, you can't do something to one side of an equation unless you do it to the other side. I multiplied the left side by negative 2, so I also have to multiply the right side by negative 2. So this is what my system looks like now. And again, the advantage is if I add my equations together now, these two terms will drop out, and I'll only end up with y terms. Negative 4 and positive 4 is 0. Negative 6 and negative 5 is negative 11y. And negative 14 and negative 2 is negative 16. What a simple little equation we end up with once we eliminate one of the variables. All I have to do now is divide both sides by negative 11. And a negative divided by a negative is a positive. So we're half done. Okay? We have figured out that the y coordinate of our point is 16/11. Now, think about what I did. I eliminated x so that I could find y. Well, I'm just going to come back up here and start over again. This time, though, I'm going to eliminate y so I can find x. I look in front of the y terms. I see a positive 3 and a negative 5. This is kind of like finding common denominators. If you were adding thirds and fifths, you would turn them both into 15ths. 15 would be the common denominator. It's called the least common multiple. Well, if I multiply this one by 5 and multiply this one by 3, then this will be a positive 15 and this will be a negative 15. And when I add them together, they'll go to 0. So that's my plan. I'll multiply the top one by 5 and the bottom one by 3. So the top equation, I got to multiply 5 times everything. So I get 10x plus 15y equals 35. And the bottom equation I'm multiplying by 3, so that's 12x and negative 15y equals negative 6. So there's my new system. And now when I add those equations together, this time the y's get eliminated. I get 10x plus 12x, which is 22x. And I get 35 minus 6 on the right-hand side, which is 29. So when I divide both sides by 22, I get my x-coordinate. Now we always write our answer as a point, and we always put the x-coordinate first, so our solution would look like this. X is 29 22s, and y is 16 11ths. Okay? Very strange looking numbers, but that's what happens when you just make questions up off the top of your head. Now, to review, what we did was we first eliminated x so that we could find y, and then we eliminated y so that we could find x. But sometimes strange things happen. Let me show you one strange thing that can happen and see if you can anticipate what it means. Suppose my first equation was 6x plus 10y equals 7. And my second equation is negative 9x minus 15y equals 3. Okay? So let's first eliminate x. Right now I've got a 6 and a negative 9, but I could turn those into what? Think of the least common denominator, the least common multiple. Jackson?
18.
18, yeah. I could turn this into an 18 by multiplying by 3, and this would be a negative 18 if I multiply it by 2, right? So I get 18x plus 30y equals 21. And I get negative 18x and negative 30y equals 6. And so when I add these two equations together, something strange happens. Because the x's drop out, but so do the y's. So the left-hand side is just 0, and the right-hand side is 27. And we've seen this sort of thing before. I don't care what x and y are, 0 is never equal to 27. What does that tell me?
Two parallel lines.
Yeah, there's no solutions. These must be parallel lines. Okay? And if I just change these numbers over here, so it's now going to be a new problem. If this would have been, let's say, a 14 and this one a 21, then when I multiply this one by 3, the right-hand side would have been 42. Oh, I guess I better make one of them negative. And when I multiply this one by 2, I get a positive 42. And now when I add them together, even the right-hand side is 0. Okay? And that statement isn't false, it's true. It's always true, which means we have how many solutions?
Infinite number.
Yeah, an infinite number. These are actually the same line. Okay? We've seen before that there's only 3 things that can happen. You get 1 point, no points, or an infinite number of points. And this is what it would look like if you got an infinite number of points. By the way, the same thing could happen with the substitution method. You might end up with an equation that has no solutions or an infinite number of solutions. But I always use this method if everything is nice and lined up. And what I mean by that is I've got an x over an x. I've got a y over a y. I've got a constant over a constant. If things are lined up that way, it's really the quickest way to use the elimination method. So let's do one last example. Let's see. Suppose we have 5x and negative 3y equals 4. And this one's going to be 2x and I'm going to get a different sort of an example here. 7y equals 1. Now you can do this in either order you want. You can eliminate x first or you can eliminate y first. Let's just do it in alphabetical order. Let's eliminate x. So right now I have a positive 5 and a positive 2. So anybody got an idea? Rebecca?
The least common denominator would be 10.
10. So you want me to multiply this one by
2.
and this one by?
Negative 5.
Aha. If we multiplied by 5, then we'd have 10 and 10, and those don't add up to 0. We want to get two numbers that add up to 0. So it really didn't make any difference if she made this one negative or this one negative. But you want to get one of them positive and one of them negative. And your suggestion was this one was negative, I think, right? Okay, good. So we would get 10x and negative 6y equals 8. And down here we would get negative 10x and negative 35y equals negative 5. Again, we get some weird looking fractions here, but it's not bad arithmetic at all. Because when you add these together, the x's drop out, we get negative 41y is equal to 3. Right? So we're half done. Y is negative 3 41s. Okay? Good job, Becca. Now, Isaac, you're going to eliminate the y's for us.
So I would multiply the top one by 7 and the bottom one by 3.
Yeah, they're already a negative and a positive, so he multiplied both of them by a positive. Now we'll have negative 21y and positive 21y. That's all there is to it. So let's do it. We get 35x minus 21y equals 28. And we get 6x plus 21y equals 3. Okay, so add them together for us, Isaac. 35x plus 6 more x.
Yeah, plus 6 more, so it'd be 41.
41x. These add up to 0, which is good. What's the right-hand side?
So it would be 28 plus 3, so that'd be 31.
Yeah, exactly. Okay. And to get rid of the 41, we would?
Divide both sides by 41.
Good. So now we've got our x. It's 31 41s. That'll happen a lot, by the way, that the fraction will have the same denominator, but not always. All right, that's the elimination method, and by far that is the preferable method, I think, for solving a system of linear equations.